In the previous videos, we mainly focused on how data and information are stored and represented inside Python. We talked about the basics of Python data structures, from simple data types to composite data types. Now let's spend some time to talk about the actions we can apply on those data. We will start with loops, because loops are probably one of the most widely used operations in any kind of computer programs for executing repetitive tasks. And if you have experiences with other programming languages, you will discover that Python actually has a quite different way of using and constructing loops. So in this video, we're going to talk about loops. And the first thing we're going to do is talk about the syntax of loops. Syntax of for loops. The so-called for loops. If you haven't actually heard about for loops, we're going to sort of take a look at it. Now, suppose we have a list of complex numbers. Let's just call it complex numbers. And it equals to 3 plus 4j, 6 plus 8j, 9 plus 12j, and 12 plus 16j. Right, we talked about how to construct lists in previous videos. Right, so here we have constructed a list of complex numbers. Right, those j is the unit, imaginary unit. Right, so imaginary unit. So if you are not familiar with complex numbers, that's also okay, because complex numbers are only used in sort of very specific scientific computing work, right? But you can actually just think of this particular list as a list of like a 1, 2, 3, 4, 4 numbers, right? Doesn't really matter what kind of numbers they are. If it's just like 4 numbers, right? Doesn't really matter what kind of numbers they are. You can think of it as integers. You can think of it as floating point numbers, right? Here I'm using complex numbers, but the nature of this imaginary unit is not really the focus. And then suppose we wanna print out, for example, the absolute value of each complex number inside of this list. We can write a loop to do that, right? So for complex number in complex numbers with an S here, right? And then colon, print ABS complex number without S, right? Let's run it. So it's gonna print out the absolute value of those 4 complex numbers. It's 5, 10, 15, and 20. Right? So 5, 10, 15, and 20. Both the for and the in here are Python keywords, and this loop structure is what we call a for loop. Basically, this thing here is called a for loop. So the first line, this line of the for loop construct tells Python to basically retrieve the first element from the complex numbers list. This list of complex, that's called complex numbers, from this particular list, and then store that first complex number, the first element that you have retrieved from the complex numbers list, into a variable. Store that element into the variable that's called complex underscore number. And then Python will read the second line here of the for loop construct, and then calculates the absolute value by calling the ABS function. It's going to compute the absolute value of the complex number that has been stored into this complex underscore number variable. And then it's going to call the print function to print out the absolute value that has been computed, which is actually 5. Right? And because the list complex underscore numbers, this list contains more than one elements. So Python now, after it finishes executing this line, it's going to return back to the first line. And then retrieves the next element inside of this list, complex underscore numbers. And again, stores that complex number, the second element, inside of this variable that's called complex underscore number. And then Python is going to execute the second line of the for loop construct again, which will compute the absolute value of the second complex number, this number that's stored in the list, right? And then prints out the result, which should be 10, right? So Python will actually just repeat this entire process until it finishes processing the last element inside of the list of complex numbers. When we write the for loop construct for our specific problems, we need to keep in mind that we can choose any valid variable name for this temporary variable that's going to hold each element that comes out of this particular list. So, for example, if we change this variable name to just a C, if we change it to C, right? We change it to C here, right? The code will work equally well. It's still going to run, and it's still going to print out all the correct values, right? But it is important to remember that if we change the temporary variable name in the first line of the construct, we must remember to change the names of all the occurrences of this particular variable inside of the body of the loop. So after we have finished writing the body of the loop, we can continue to write other lines that are outside of our for loop, right? So suppose the for loop has finished. That we have finished writing the for loop. So we can continue to write the rest of our program, right? Suppose we write out another string, no more numbers, right? And then let's execute again. Then it's going to print out the absolute value of the 4 complex numbers, and then no more numbers, right? Another string. So if you are coming from a different programming language, such as C or C++ or Java, you may think that the indentation here, for example, I have an indentation here, right? But there's no indentation in front of this particular print, right? You might think that the indentation here in Python is just a styling issue that makes the code more readable. But in fact, in Python, those indentations are actually syntactically important. If we do not indent those lines correctly, the code will behave in unexpected ways. So suppose we forget to indent the line for printing the absolute values. Suppose we get rid of the indentation here, right? Then let's run it again. And this time we get an indentation error, expected an indented block, right? So the code will not run. It's an indentation error. It's not going to run, right? So for now, the body of the loop has only just one line inside of it, right? Suppose we also want to print out, for example, the imaginary part of each complex number, right? So let's still put this line back, right? Suppose we also so this line now has the correct indentation now, right? So suppose we also want to print out the imaginary part of each of the complex number. So we can just print out this particular data member of this object, right? We can just add this line to the inside of the body of the loop body. Then let's run it again. So this time it's gonna print out for every iteration. It's gonna print out two numbers. The first number is gonna be the absolute value, and then the second number is gonna be the imaginary part. So for the first element, the absolute value is 5, and the imaginary part is 4. The imaginary part is basically the number in front of the j, basically. Right? And then for the second iteration, the absolute value is 10, and then the imaginary part is 8. So it's gonna sort of behave in this particular way. Right? That's the expected behavior, right? We want this kind of behavior. But suppose again I forget to indent. The second print. Then what's gonna happen, right? Is it still gonna give you an indentation error? Right? This time it's not gonna give you an indentation error. The code actually runs, but the behavior is not exactly what we wanted the behavior. Right? So what we are having here is that we're getting the absolute value printed for all four numbers. So the absolute value here for the first number is 5, and then 10, then 15, then 20. 5, 10, 15, 20. So the absolute value for every element inside the list has been printed, right? But the imaginary part, we are not printing the imaginary part for every number. We're just printing the imaginary part of the last number, which is 16. Which is 16 here. And then no more numbers, right? The reason that we are getting this behavior is that, so if we forget to indent this print line, Python will consider this line as a line that's outside of the for loop construct. So it will execute this line only after it has completed all the iterations in the for construct, in the for loop construct. So it's gonna keep doing this particular loop until all the numbers inside of this list has been exhausted. So it's gonna keep printing the absolute values for every number, right? And after it has finished printing the absolute values for all the numbers in the list, it will execute this line once. And when it actually comes to this line, the variable c, is gonna have the value that's stored inside of the last element, which is 12 plus 16j, right? So when the loop actually finishes, the last iteration has completed, the variable c is going to have the value that's in the last element of the list. And then at this point, if you print the imaginary part of c, then it's just going to print 16. Right? So this line is considered lying outside of the body of the loop. So this line is not going to be iterated. It's just going to be executed once after the for loop has completed. So on the other hand, let me put this line back into the correct indentation. On the other hand, if we indent unnecessarily the third print output, suppose this line is supposed to be sort of not inside of the loop body, right? But suppose we actually indent it incorrectly, right? Then what's going to happen, right? Let's run it again, right? So this line is inside of the loop body, is considered inside of the loop body. So it's going to be executed every time when there is an element inside of the loop, inside of the list. So this is going to be, so print no more numbers. This particular no more numbers line is going to appear after every iteration, right? For every iteration. So we have like 1, 2, 3, 4, 4 numbers. So no more numbers is going to appear like 1, 2, 3, 4, 4 times. Right? So for every iteration, it's going to first print the absolute value, 5, and then print the imaginary part 4, right? For the first element, it's 4, right? And then it's going to print no more numbers. And then it's going to go back to execute for the second element, right? The absolute value printed again, 10, and then the imaginary part, that's 8, and then no more numbers again, no more numbers, right? Again, this is not the behavior that we want, right? So the indentation is actually very important. It's very important, right? And remember that if you have just one line for the loop body, then it's gonna report indentation error. But if you have multiple lines in the loop body, it's not gonna report indentation errors. It's gonna execute, but with the incorrect behavior. And then another thing that we have to sort of pay attention to is the colon here. We have a colon. We have a colon behind this for statement, right? And if we forget the colon, suppose we get rid of the colon, then it's actually a syntax error. If we run it, it's going to tell us it's actually an invalid syntax, right? And so the colon must be there, must be there. So in addition to the indentation, the colon here is also syntactically very, very important, right? So basically, that's all I have to say about the syntax of the for loop. If you have used C++ or Java before, you will notice right away that this Python for loop is actually very similar to the so-called for each loop in those languages. But in Python, this behavior of the so-called for each loop is actually the default or native behavior for the for loop in Python. So if you have programming experiences in a language that uses for each construct, right, and then the Python for loop is kind of very similar to the for each loop that you have experience with. For C++ programmers, a more natural way of writing a for loop is actually to construct the index in the for statement, right? In a C++ program, you write a for loop by actually explicitly manipulating the index, right? So in the for statement, you actually specify the starting value, the ending value, and sort of the stride of that index. And then inside of the body of the for loop, you use the index to retrieve those elements that's inside of the a particular data structure, right? So if you want to sort of replicate that kind of behavior, that's sort of not a very encouraged way of writing codes, but you can do that in Python. Suppose we do this thing. For I in range len complex numbers colon print abs complex numbers I, right, and then print right. So here the len function is gonna return the length of the list complex numbers, and then the Python range function will return integers that go from 0 to the length of the list subtract 1. So this I here, will take upon the value of each of those integers, and inside of this loop body, this I is used to index into this particular list to retrieve the elements, basically, right? And in Python, this kind of code is discouraged, and is actually slower, less efficient in terms of performance. In Python for loops, what we should try to do is to avoid using those kind of indexes, right? to avoid constructing indexes explicitly and avoid using index to index into a particular data structure. So this is actually bad code in Python. In C or C++, this is actually considered good code, right? It's at least a normal code. So let's comment out this piece of code. Right, this is actually bad code in Python. One of the justifications for using an index in the loop is that sometimes we may need to loop through a list backwards, right? So if we are still using this kind of index in our loops, we can actually achieve this kind of backward iteration without too much of a difficulty. So for I in range, so now we have to, instead of go from 0 to the length of the list subtractor 1, we go from the length of the list subtractor 1 the length of the list subtractor 1 to minus 1 to 0 actually, right? Because for the range function, the second input is kind of excluded, right? That's the upper limit of the sort of range, right? And the upper limit of the range is actually excluded. Only the lower limit is actually included, right? And then the stride is going to be minus 1 also, right? So we're going to start from, so I is going to take upon the value that's the length of the list subtractor 1. That's going to be the first value in I, right? And then the last value in I is going to be 0. And then the stride, the last input to the range function, is going to be minus 1. So I is going to actually reduce, right? Has reduced value. So if we do that, print ABS complex numbers I, and then print no more numbers, and then we can execute it, right? So this time it's gonna go from like the last number actually has a normal has a absolute value of 20, and then go to 14, 15, 10, and then 5, right? So it's gonna loop backwards. But in Python, again, this uses index, right? And Python actually discourages you to use index inside of a loop. So again, this is bad code in Python. So what's actually the correct way to do things in Python, right? If I actually want to loop backwards, so how am I supposed to do that in Python, right? So the correct way is doing this. We call the reversed function on the complex numbers list. And then inside of this loop, we still just print ABSC. And then print no numbers. And it gives you exactly the same behavior. And the code is actually more clear and more direct. It tells you right away what this code is actually doing, right? Without using the index, you actually achieved a better readability. And in Python, this is actually a lot more efficient than actually using indexes in terms of performances. So the reversed function, the key here is in using the reversed function that's provided by Python. And this reversed function actually returns something. It's not going to reconstruct a new list. It's not going to do that. It's not going to reconstruct a list. If you try to reconstruct a list, then there's going to be a memory overhead and then also a CPU overhead, right? But it's not going to do that. It's going to return something that's called an iterable, right? If you have used iterators before, this reversed function has very little overhead. It's going to return a iterable. So it's not going to sort of consume more memory or sort of reduce the CPU efficiency. It's actually very, very efficient, right? So the key here is to use the reversed function, right? So that's looping backwards. That's looping backwards, right, inside the list. And again, there's no need for indexes in a loop, right? But what if we need to iterate through a certain portion of a list instead of the entire list, right? In C or its variants, this is again achieved by controlling the index in the for statement, right? Inside of the for statement, you can specify the starting value, the ending value, and sort of the range of the index, right? But in Python, it is actually better to slice the list instead of controlling the index. Again, we don't have to use the index. So for C in complex numbers, so suppose we just want to iterate a certain portion of the list that goes from the 0th element to the end of the element, and then with a stride of 2, then print ABSC, and then print no numbers. So this time we're just gonna print the absolute value of the zeros, and then with a stride of 2, and then the zeros, and then the second, right? The zeros absolute value, and then that's the first, and then that's the second, right? So the absolute value of this number is 10. The absolute value of this number is 15. So it's supposed to be printing 5 and 15, right? We talked about how to actually select certain portions of a list by using this kind of a colon inside of square brackets, right? We were calling this colon as the sort of range operator, right? We're using this kind of a range operator inside of the square brackets to select elements from a list in the second video, right? We talked about this kind of a selecting, or in Python it's called a slicing, this kind of slicing operation in the second video, right? And in that video I was saying that by slicing a list, or by selecting a list using this kind of range operator inside of a square bracket, we were creating a deep copy of that list, right? By creating a deep copy, which means that we're actually allocating new memory, and then duplicating that list inside of the new memory, right? Which is actually a very expensive operation if the list is sort of very long, right? But if we actually slice a list in the for statement, inside of this particular for statement, it's not going to create a deep copy. It will actually create a shallow copy. So there is no memory or CPU overhead involved in this particular selection or slicing operation in Python. If you don't believe me, we can try to print out the ID of the variable C inside of the loop body. Okay, just add this line into the loop body. This ID function will return the unique identity of any object in memory. And then we can compare it with the ID of the corresponding element in the list and see if they are identical, right? Let's just run it. And then it's going to print out the ID before it prints out the absolute value. Right, this very long number here is actually giving you the ID of the C here. Right? The ID of the C here. C is what? C is actually taken from this slice. Right? C is actually used for storing the value inside of the slice. Right? And then let's look at the ID of complex numbers. So C is gonna go from 0 to like a second, right? So let's look at the ID of the zeros, and let's see if they are identical. Right? So they are indeed identical. Right? They are exactly the same. And then let's look at the ID of the second element inside of the complex numbers list. again, they are exactly the same. They are exactly the same. Which means what? Right? Which means that no elements were duplicated during the loop. No new memory was allocated. Right? So both C, that's taken values from this particular slice, and the original list, which is the complex numbers here, right? They are actually pointing to exactly the same memory space. No new memory was allocated, right? So even if this particular list is very, very long and very, very complicated, slicing it or selecting elements from it using the slicing operation inside of the for statement will not slow down our code in any way, right? But sometimes we may still need to actually loop through the elements and also their indexes at the same time, right? In C or its variants, it is not a problem because it's manipulating the index directly. But in Python, we are not really using the index. We are trying to avoid using the index. So what is the correct way to actually get the index within the loop body, right? So in Python, the correct way for doing that is to do this. So for I and C, right, in enumerate. Enumerate is another function, is another Python function. Print I abs C, and then print no more numbers. Right, let's just run it. So this time it's gonna print two numbers, I, and then the absolute value of C. Right, I first followed by the absolute value of C. Right, so that's I, and then the absolute value of C. So I goes from 0 to 1 to 2 to 3. That's exactly what we wanted. It's an index. Right, it's an index, but it's the index not created by us, but it's the value of the index actually comes from this particular enumerate function. And this enumerate function is going to return on the fly. It's going to return on the fly an index value pair for every element inside of this particular list that's used as the input to enumerate function. Right. So what you can actually think about inside in this piece of code is that the enumerate function is going to create on the fly. So those kind of integer complex number pairs, right? The complex number is going to come from this particular list, and that integer is going to be created on the fly. And then that integer, that index is going to be assigned to I. And then the complex number is going to be assigned to C. Right? If you have to use the index, then use this index that's created on the fly by the enumerate function. Right? And inside of the loop body, we are not really using the I to index into the list. Right? We're basically just sort of printing it. Now suppose all those complex numbers in our list are actually associated with variable names. They are not exactly associated with those integer, right? That's created by enumerator that goes from like 0 to 4. Suppose they have variable names that comes with it, right? And those variable names goes from the letter A to arbitrary letter number, right? A to G, for example, right? And we want to sort of print out the name of the variable followed by its absolute value. So how we are going to do that, right? So in this kind of a situation, we basically have to sort of loop through two lists, which may not have exactly the same length, right? And we have to loop through them in just one loop body, in one loop construct. So one of the lists is going to be used to store the names of the variables, and the other list is the complex numbers list, right? So how can we actually do that? Let's come up with a string that's going to be used for storing the variable names, right? A, B, C, D, E, F, G, right? Each character is for one complex variable, right? And then we can do this thing. For name C in, here we're going to call the zip function provided by Python. C names as its first input, and then complex numbers as the second input, colon, and then we're going to print. So name is going to be a string plus has modulus space plus str abs c. We're going to do that, right? So the key here is in using the zip function. It's in using the zip function, right? The zip function is going to keep returning a pair with one element from each list until the shorter list runs out. In this case, the shorter list is actually complex numbers. It's got 4 numbers in it, right? But the A, B, C, D, E, F, G is like a 1, 2, 3, 4, 5, 6, 7, 7. It's got seven characters in it. Right. You may want to say that the C names here is not really a list, right? It is actually a string. Yes, that's true. That's indeed true, right? But what we haven't talked about is that a string is also something that's called an iterable in Python. So what exactly is an iterable, right? So what exactly is an iterable? Let's talk about iterable. Or iterables. Maybe I should use the plural for right? In fact, everything that we have seen after the keyword in, after this keyword in the for statement, inside the for statement, is an iterable. So everything that we have seen here so far, everything, so including this list, right? Including this list, including this thing that's returned by the reverse function, including the thing that's sort of returned by this slicing operation, the return type by the enumerate function, the return type of the zip function, all of those things that's after the in keyword are iterables. Those are called iterables in Python. It's a specific kind of a class. It's a specific kind of a object that implements a method that's called iter, iter, right? We can also put a string behind the in keyword. So if we just for name in C names and then print name, right? And then let's print two new line symbols behind this loop, right? We're gonna see every character inside of the CNAME string being printed out, right? So we can actually put a string behind this in keyword, and then we can use the string as a iterable, and then we can actually loop through every character inside of that string. So an iterable is something that's basically can produce a stream of values or objects, basically. The iterable itself decides what kind of values or what values or objects it will produce. In a for loop, we can assign each value or object produced by the iterable to a name, right? And then we can execute statements for each value or object produced by the iterable. So basically, iterable is actually a very general concept. Lots of things in Python are actually iterables, and many functions takes iterables as inputs and return iterables, right? The enumerate function, the zip function, the reversed function, all of those functions actually return iterables. The string is an iterable. The composite data types, including the list the set and the dictionary that we talked about in previous videos, they are all iterables. So let's construct a dictionary. Let's try to construct a dictionary for our complex numbers by using the dict function and also the zip function. We're going to call the dictionary, call it cdict. Cdict equals to dict zip cnames complex numbers. So here the zip function is going to take two iterables as its input. Right? Cnames is a string, but it's also an iterable. Complex underscore numbers is a list. A list is also iterable. So the zip function is going to take two iterables. And then the zip function itself is also going to return an iterable. And then the dict function, this particular function, dict function, it's going to take the iterable created by the zip function and then creates a dictionary. And that dictionary is assigned to cdict. The dictionary is iterable, so we can use it inside of a for loop. So for, that's a ck in cdict, right? It's an iterable, so we can actually use it behind the in keyword, right? And then let's just print out what's going to be the ck, right? What's going to be the value of ck? Again, let's print out two new line symbols after the iteration. It's just going to print out ABCD. ABCD is what? ABCD are the names. It's the variable names. It's the variable names that's become associated with each of the complex numbers. Right? That's the key. Basically, that's the key to each of the values. Right? It's the key in every key value pairs that resides in this particular dictionary. So by default, the default behavior for a dictionary, if you use the dictionary itself as the iterable here in the for loop, then the default behavior is that this iterable is gonna return a sequence of keys, a stream of keys, and then this ck, this variable here is gonna take upon every value in that stream of keys of that dictionary, and then it's gonna print out the key that's stored inside of it, right? So if we want both the keys and the values, we can do this ckcv in cdict. This time we're going to call a function that's called items. And then we're going to print ck plus a colon plus strcv. And then print and then this time it's going to print the variable name first, and then the complex number that's associated with it. So it goes from A, B, C, D. Right. And if we only want the values without the keys, we have another function, we have another method. It's called values. So this time it's just going to print out all the values without the key that's inside of, without the variable name in front of it. Right? So in our execution, in these two executions of the two loops, the elements in the dictionary happened to be printed out in the kind of a insertion order, right? Each of the elements, A, B, C, D, that's sort of each of the elements were inserted in this particular order, right? And the printout happens to actually give you this particular order, right? But we cannot really rely on this behavior. We cannot rely on this particular behavior when we actually write our practical code, right? The ordering of elements inside of a dictionary is actually undefined. If we want a dictionary that can remember its insertion order, we must use another data type that's called ordered dict. which is in the collections module, right? And this particular ordered dict data type also supports sorting of dictionary elements, right? But here we are not really using that ordered dict. We are just using the native dictionary that's provided by Python, right? The ordered dict data type is inside of the collections module, and here we haven't actually imported any modules in our script yet, right? So even though there is no particular ordering to a dictionary, but when we try to iterate through it, when we try to iterate through those values and the keys inside of those dictionary, it gives us its elements in an unexpected order, right? But we cannot sort of rely on that printed out, the order that's taken by these particular iterations, right? Because the ordering is actually unspecified. It's undefined. The same is actually true for Python set. For Python set, right? If we create a set from the complex number list and loop through the set, the order is also undefined. So for dictionary and set, these two composite data types, there's no inherent ordering in it. So let's create a set. Let's call it C set equals to set complex numbers. Here we're actually giving the set function a list. Basically, but the set function actually takes more than just the list. It can also take iterables, just like the dict function. It can take iterables as its input. And for C in C set, print C, and then print no more numbers. Right. But here you can sort of see the ordering is like the opposite. It's actually the reverse ordering, right? Just the reverse of the insertion ordering. Right. So the ordering that's taken by this particular iteration is also undefined. Right? It's undetermined ordering. In Python, many functions take iterables as inputs and return iterables as outputs. The range function, right? The range function reversed enumerate the zip function, and then the slicing operation all return iterables. And one particular example that we might want to pay attention to is the range function. Right? It's the range function that we used in these two commented out codes, right? In these two bad code examples, right? The range function. The range function is actually used quite often. It's actually used quite often to generate an iterable of just the integers, right? And in Python 2, the range function actually returns a list. So here this is inside of a terminal, so I'm going to call Python 2.7. So here I'm actually using Python 2.7 inside of this particular terminal here. Right. It's a 2.7.10. So the return type of a range is going to be a list. So if I type range 5, then it's going to return a list of from 0 to like 4, right? So if I have just the one input, then it's going to use that input as the upper bound of the sequence of the list. The lower bound is automatically set to 0, right? But if I actually range, I'm going to give like 2 to like 10 with a stride of 2, then it's going to give me this particular sequence of numbers. So if you try to check the type of the range function, of the return type, the return type of the range function, you're going to see a list. So basically, the range function in Python 2 is going to return lists. If the input to the range function is small, like this kind of thing, it's not really a big problem. But if the input is really large, so suppose I give it like a 10 billion here, then the list created by the range function is going to occupy a huge chunk of memory. Right? It's going to consume lots of memory. Right? The list is too big. But inside of the for loop, if we use a range as sort of the iterable inside of the for loop construct, we are not really using the entire list in each iteration. So all we are using inside of the loop body in each iteration is just one number from that huge list. So to avoid this kind of problem, Python 2 provides another range function called xRange. This xRange is not going to sort of return a list. It's not going to do that. It's not going to return a list, right? It does not actually create the entire list at all. It only returns one integer per iteration. So for I in xRange 5, print I, and then you're going to see 1, 0, 1, 2, 3, 4, right? So for every iteration, xRange is just going to return one number. Right? It's not actually constructing the entire list, right? So it avoids this kind of huge memory problem. And the return type of the xRange function is actually an iterable. It's not a list, it's an iterable, right? And inside of Python 3, inside of this Python 3, the xRange, so this is inside of Python 3. This is Python 3. And in Python 3, xRange function has been removed. If you do type help xRange, it's going to tell you name xRange is not defined. So you don't have the xRange function inside of Python 3. But the default behavior of the range function has been changed to be identical to that of an xRange in Python 2. Right? So if you actually look at the type of range 5, it tells you it's a range. A range is an object that's a subclass of iterable. Right? It's not a list. If you do range 5, it's not going to return a list for you. It's not going to return a list for you. Right? So let's do a print type range. Let's use a more complex. Use 3 inputs. So the range is going to start from 2, end with 10, and with a stride of 2, right? And we are printing the type of the returned value by the range function, right? And then let's print out something else. Here we're actually using the list function. So the output of the range function is going to be used as the input to the list function, right? So if we want a list from the range function, we have to do this explicit conversion by using the list function. And then if we run this code, so the printout of the type is a class of range, and then the printout of the list of the range output is going to be a list 2, 4, 6, 8 to 10. The return type of the zip function, we looked at the range function. The return type of the zip function here, the return type of the zip function is also different between Python 2 and Python 3. And in Python 2, the zip function returns a list of tuples. But in Python 3, it returns an iterable. And if we want a list, we must do the explicit conversion using the list function. So if we want to look at the zip behavior, so let's print out the zip of 2 ranges, 5 and then range 7. Then it's going to print out a list of tuples. And the first element of each tuple is going to come from the first list, the first iterable that goes into zip. And then the second element of each tuple is going to come out of the second input, right? So if you check the type of the zip output, range 5, range 7, so it's going to be a list, right? But in Python 3, In Python 3, it's not true. It's not the same thing. So print type zip range 5, range 7, and then print list zip range 5, range 7. So in Python 3, the type of the zip output is going to be a class of zip, which is a subclass of iterable. And then if you want a list of tuples, you have to use the list function to explicitly convert the output of zip into a list of tuples. The iterables are useful not only inside the for loop, they can also be used in many different ways and allow us to actually avoid writing an explicit for loop construct. So we have seen many Python functions such as the list, dict, set, and zip functions. They are all taking iterables as inputs, right? And another very useful function that takes an iterable as input is the join function defined on a string, which allows us to do concatenation with a lot of ease, right? So let's look at string concatenation. We can certainly do string concatenation by using a loop, right? Suppose we initialize a string with an s with an empty string, and then for c in c names, right? And then s equals to c plus, right? And then we can just print s, or we probably let's still print s. So S is going to look like a concatenation of every character inside of the C names, but with this delimiter, this dash as a delimiter, right? If we don't want this particular delimiter, we can change it to something else, or just the empty string. It doesn't really matter, right? So here we initialize S with an empty string, and then in each iteration of the for loop, we append one character from the C names string, together with the dash, the delimiter, onto S. But remember that the Python string is actually immutable, right? You cannot actually modify a string. So what Python is actually doing inside of this for loop construct is that it's going to create many intermediate strings during the concatenation process. And this process can be creating those intermediate strings, involves allocating new memory, and involves sort of garbage collection if you have lots of these kind of concatenation processes, right? So it can be very inefficient, very expensive if we need to concatenate lots of strings together. And a much more efficient way. So again, this is bad code. So let's still comment out of this portion of the code, right? The correct way for doing that is just by using the join function that's defined on a string. And the join function takes an iterable as input. So here we are calling the join method, not function, a join method on the delimiter string, which is a dash here, right? But it can be anything. It can be just an empty string as long as it's some kind of string, right? And then you can call the join method on that string, and then the join method is going to take an iterable as its input. And here C names is a string, and a string is also an iterable, right? So the join function is just going to take every character inside of the string, concatenate it with the delimiter, and then produce the final string that you want. It's going to give you the correct result here, right? That's a string concatenation in the doing it in how string concatenation is supposed to be done in Python. And another example where we can use iterables is the so-called list comprehension. In fact, we can construct a list by transforming another iterable. So let's construct a list. Let's call it CLST. And then we're just going to have a square bracket. And then inside of the square bracket, we're going to construct our for So it seems that we're actually embedding a for loop inside of a pair of square brackets. But in this particular example, every I value that's provided by this iterable is going to be used to generate this particular expression, to evaluate this particular expression. So the real part is going to be I squared, and then the imaginary part is going to be I modulo 2. So essentially, we are basically just transforming this particular iterable, which actually has a range that goes from 0 to 4, into this list. A list is also an iterable. We're just using this kind of list comprehension to transforming one iterable to a list. Let's just run it. And then we're going to see a CLST, C-list here. It's a list, has 5 elements in it. The first element is 0j, which is because I takes upon the value of 0, right? So 0 squared is 0. 0 modulo 2 is 0. 0 times 1j is 0. So it's just the 0j. And when I takes upon the value of 1, 1 squared is 1. 1 modulo 2 is 1. So it's 1 plus 1j. And then when I equals to 2, 2 squared is 4. 2 modulo 2 is 0. Right? So it's 4 plus 0j. And then I becomes 3. 3 squared is 9. 3 modulo 2 is 1. Right? So it's 9 plus 1j. So that's how list comprehension can be done. It allows you to transform one iterable, that's range 5, into this list with this expression for generating its elements. Right? This comprehension technique can also be applied to construct Python sets and dictionaries from other iterables. So let's call it C set 1 equals to, say, I cube to the third power plus I multiplied 2 times 1j, right? For I in range, let's give it like 6, right? So here we're generating a C set with 6 complex numbers in it, right? So C set 1, right? The ordering is supposed to be unspecified, but it happens to print out in an insertion order. Oh, not exactly in the insertion order. So 8 plus 4j is actually smaller than 27 plus 6j, right? So this element is supposed to go for first, but because it's a set, there's no so the ordering is undefined. And then we can do a cdict 1 equals to, so k dot upper, we're calling the upper function defined on the key absv, taking the absolute value of the complex number for kv in cdict dot items. So in this dictionary comprehension, the for loop seems to be slightly more complicated. We have both key and the value. The iterable is returned by the dictionary items method, right? And then for every key value pair, we're transforming key. We're converting the key, which is supposed to be a string, to an uppercase, and then we're computing the absolute value of the value here that's returned by the for loop, right? And then use the absolute value as a new value, right? So let's try to generate this cdict 1. So cdict 1 here, right? And then all the keys become capital cases, right? It's no longer small case a, it's capital case A. And the absolute value of the complex number, that's 5, 10, 15, 20. right? That's comprehension. Comprehension. And then another utility of iterables is in some of the statistical functions. Some statistic functions. Some statistic functions also take iterables as inputs. For example, the sum function. The sum function is gonna do a summation. It's gonna return a summation. It's gonna return basically the total of everything that's inside of an iterator. So cdict values is gonna return a iterable, and then sum is gonna take that iterable and compute the total of all the values of all the stuff that's inside of that total, inside of that iterable. So here it's 30 plus 40j. So all the complex numbers inside of cdict, you add them up, it's going to be 30 plus 40j, right? And another, the min function is going to cdict 1 this time. And then we also have a max function. All of them are going to take iterables, right? Min is going to return the minimum value, and then max is going to return the maximum value, right? All of those statistical functions take iterables as inputs, and then it's going to just do some calculations on all the stuff that's inside of that iterable.